It says Richard.
Well, good evening, everyone. This is Gerald McKeegan up here at the Chabot Space and Science Center. I'm up here in the observatory for our 36-inch telescope, Nellie, which you can see behind me here. We're supposed to be doing virtual telescope tonight. Unfortunately, Mother Nature has other ideas. It is cold, it is windy, it is very cloudy up here. So we are not going to be able to do any observing through the telescopes. We won't be able to hook any cameras to the telescopes or anything like that. However, we are going to share some things with you. We're going to talk a little bit about current events coming up in the wonderful world of space. And then we are also going to show some images taken with this telescope. Last week we did this, and we were told afterwards that some of you kind of checked in a little late and you missed some or all of the images that we showed. So we're going to show the same ones again this week, but we're going to do it a little different. We're going to show you a little bit more about where to find these objects in the sky, tell you a little bit more about the constellations that they're in and so forth. So what I like to do is get started here, and bear with me while we do some computer stuff here. We need to find PowerPoint and click on it, and then, oops, back one. Bear with us here. Sorry. Yeah, Richard Ozier up here with me, and Richard is going to be doing a couple of things as well. And he's the computer guy. I'm the guy that hates computers. He's the guy that likes them. So he's helping us out here. All right, so we're going to talk a little bit about our observatory telescopes. You see a picture here taken actually several years ago of two of our telescopes. The big one on the right is Rachel. The little dome on the left houses Leia. Rachel is a 20-inch refractor. Leia is a 8-inch refractor. The telescope you can't see is Nellie, which is the telescope that we're in right now. So I want to get started by talking about some upcoming events. And the first one I want to talk about is one that's going to happen later on this month. And let's see if we can make that happen. There we go. So on May 27th, the United States, NASA will finally resume launching NASA astronauts from US soil. The SpaceX Crew Dragon will be launched from pad 39, I think it's 39A at Kennedy Space Center. They will launch at 1:33 p.m. Pacific time. So if you get a chance, you might actually be able to watch that launch. There will be two astronauts on board, two NASA astronauts, Bob Behnken and Doug Hurley. And they will take off, like I say, about 1:33 on May 27th. Got a picture of them here, I think. There we go. And they are expected to arrive at the International Space Station the following morning at about 8:39 a.m. our time. Their mission is scheduled to last anywhere from 1 month to 4 months. This is a test mission. It's the first time that the SpaceX Crew Dragon will fly with a crew. And so there are some things that they'll be checking out. One of the things they're interested in is the solar panels. Earlier versions of the SpaceX Dragon spacecraft, the unmanned versions, had solar panels that stuck out to the side on like little wings that stuck out to the side. With the Crew Dragon, the panels are in the service module that's behind the main capsule. And so they are testing how long the capsule will maintain power with those new solar panels. So depending on how well the solar panels work, it could be as little as 1 month or as as much as 4 months on the space station. Again, this is the first time that the United States will be launching its own astronauts on its own spacecraft since July of 2011, which was when the Atlantis space shuttle, last time it flew. Ever since then, the United States has been sending their astronauts up to the space station on Russian Soyuz spacecraft. And if you've ever seen the Soyuz, we actually have one up here at Chabot. You know, it's very crowded and it can only hold 3 people. The Crew Dragon can actually hold, I believe it's 5 people, but only 2 will make the first flight. And they will be docking with the space station, like I said, on the morning of the 28th. And SpaceX is really encouraging people to participate in this mission. And one way you can participate is to go to a SpaceX simulation page. And if you go to that page, it's iss-sim.spacex.com. They have a simulator which will show you the same view that the astronauts will see in their spacecraft as they are docking with the space station. Earlier spacecraft, like the Space Shuttle and the Apollo spacecraft and so on, when they did their dockings, controlling the spacecraft, maneuvering the spacecraft was done with a joystick or switches and things to activate various thruster rockets on the spacecraft. With the Crew Dragon, that's not going to be how they do it. They actually will have a large computer screen in front of them with visual representation of the thruster controls, and they will be controlling it using the computer screen. So it'll be kind of touch screen computer control of the docking maneuver. Now, the SpaceX, the Crew Dragon actually is programmed to do this automatically. So in theory, they should not need to manually be involved with the docking. The spacecraft will do it automatically. But if anything goes wrong, they have the capability of taking over and actually controlling the docking themselves. This simulation that they have on their website actually shows you how they would do that. And it has some controls for what we call rotational motion and some controls for translational motion, also some controls for accelerating or decelerating. And you might want to try it and give it, just see what they experience. I'll warn you, it takes a lot of patience. This is not an easy process. The simulation is actually pretty accurate, and you'll see that it's not a very easy process. And they make it even harder because when you first start the simulation, the spacecraft is all cockeyed. So you have to straighten it up and get it to fly right before you can actually start the docking maneuver. This is not an easy thing to do, but it's good experience for you to see what's involved. I might just kind of as a side story here, back in the early 1990s, the Russians had a small space station called Mir, and some of you may remember the Mir space station. Periodically, they would get supplies in an unmanned spacecraft called Progress. And the Progress spacecraft was designed to automatically dock with the Mir spacecraft. The Russian cosmonaut who was the commander of the Mir would monitor the docking maneuver. And if he were to see anything going wrong, he could take over the docking maneuver and guide the Progress to a successful docking manually from inside the space station. Thing was, the Russian cosmonaut who did this, if it became necessary, got a pay bonus when he returned to Earth. So guess what? Those Progress supply vessels often had problems making their docking maneuvers, and the cosmonauts would take over and attempt to do the docking manually. That worked out pretty well until one time when they missed. and the Progress vehicle ended up hitting the side of the Mir space station, damaging one of the solar panels and damaging one of the compartments within the space station to where they were not able to use it any longer. So you really don't want to do manual docking unless you absolutely have to. But if you want to see what it's like, you can try this simulation. It's really a lot of fun. I've done it several times. I've got kind of an advantage because I've worked in the space industry for quite some time. So I understand this a little bit better than probably the average person does. And one piece of advice I will give you, just remember when you're doing orbital maneuvering, when things go well, they happen very slowly. And when things go bad, they happen real fast. So keep that in mind if you want to try this space simulation. Okay, another upcoming event, we're going back to Mars. In July, hopefully, the new Mars 2020 rover designated Perseverance will launch to Mars. It's scheduled to arrive in February of next year. The launch date, right now it's scheduled for July 17th, but there's some possibility that they may have to delay it a little bit. But the way it's going to work out is even if they end up delaying a few days, they will still arrive in February at Mars. They're going to land at a crater called Jezero Crater. And they will once again use the sky crane technique that they used with the Curiosity rover that is currently operating on Mars. And this is where the spacecraft comes down, lowers the rover down to the ground on a crane, basically, and then cuts the cable, and the spacecraft flies away and crashes, and the rover is on the ground ready to go to work. Couple of interesting things about this rover compared to the previous Curiosity rover. It has some additional instruments on board, still looking for evidence that life may have once existed on Mars. But one of the things it's going to do is collect samples. And it has a storage area where it will be collecting samples. And on a future Mars mission, another rover will go up and retrieve those samples, and they will be returned to Earth. So this rover is going to be collecting and storing samples for a future mission. Another really cool thing about this rover is that it's carrying an extra passenger. It will be carrying a little helicopter, which will actually take off from the rover and fly around and transmitting information back to the rover. It will actually go out and land at other locations and so forth. So that's something very new. It's going to be a bit of a challenge. Flying a helicopter on Mars is not like flying it on Earth. The Martian atmosphere is very thin. In fact, at the surface, the atmosphere of Mars is 1/100th the density of the atmosphere, sea level atmosphere here on Earth. So for all intents and purposes, it's like a vacuum. If you were to step outside on the Martian surface, you would very quickly die because essentially there is no atmospheric pressure. It's very, very thin atmosphere. But they've designed this helicopter to work under those conditions. So it'll be really interesting to see how well that helicopter works. Okay, so I want to now show you some images of things that we would have been looking at tonight had the weather cooperated with us. We did this last week, and we showed some images fairly early on in the program. And we got some feedback during the week that a lot of people, I guess, tuned in late and missed some or all of those images. So we're going to basically show you the same images, but with some more information about them. So here we go. I want you to imagine that you go outside on a clear night, like sometime this coming week. You face south And then you look straight overhead. And this is what you would see, especially if you were in a nice dark sky location. You would see a bunch of stars, several constellations up there. A couple of bright stars that you would notice would be like the one over you see over the left, Arcturus, a bright star that's about 17 light years away. It's a giant star in the constellation Boötes, which we'll talk about later. Over on the right, you see the star Regulus in the constellation Leo. Up at the top, you see the Big Dipper in the constellation Ursa Major. But right in the middle of the screen, you see what looks like an upside down L. And that is the constellation Coma Berenices. Coma Berenices is actually named after Queen Berenice of the second of Egypt. She was the wife of Ptolemy III. And according to legend, when Ptolemy went off to war, Queen Berenice vowed that she would cut off her beautiful golden hair if Ptolemy returned safely from war. Well, he did. And so she did cut off her hair, and her hair was placed in the temple of Aphrodite. But that night, the hair disappeared. And the next day, Ptolemy was very upset, was ready to take it out on the priests of the temple. But the court astronomer saved the day. He explained to Ptolemy that Berenice's hair had been placed in the sky by Aphrodite herself so that all could admire her beautiful hair. And so Coma Berenices means Berenice's hair, and it's up in the sky almost straight overhead this time of the year. So in Coma Berenice is our first object that we're going to look at, and it's located right about there. This is the object called M64, also known as the Black Eye Nebula. And this is what it looks like as seen through Nellie, our big telescope. It's a spiral galaxy that we see sort of slightly tipped toward us. And you notice it has this dark region near the center. That dark region is actually gas and dust clouds that swirl around within the spiral arms of the galaxy. In this case, they seem to be concentrated near the center of the galaxy, which gives it that black eye appearance. Gas and dust clouds like these are very common in galaxies. They are the regions where new stars form within the galaxy. So the gas and dust clouds slowly condense and form new stars. So this is M64, the Black Eye Galaxy. It's about 14.4 million light years away. Now, I'm going to use the term light year a lot, and hopefully most of you know what it means, but for those who don't, a light year is the distance that light travels in 1 year. Light zips along through space at about 186,280 miles per second. So in 1 year, light travels nearly 6 trillion miles. That's a 6 with 12 zeros after it. So light year is a measure of very long distance. And so when we say something is 14.4 million light years away, that means it's 14.4 million times the distance that light travels in 1 year. It also refers to what we call look-back time. If an object is a light year away, it takes light from that object 1 year to reach us. If it's 14.4 million light years away, it takes light from that object 14.4 million years to reach us, which means we don't see it the way it looks right now. We see it the way it looked 14.4 million years ago. And that's going to be true with all of the objects that we look at with our telescopes. We always see them the way they looked sometime in the past. If we look at a star that's 10 light years away, we see it the way it looked 10 years ago. In fact, it's even true of the moon and the sun. The moon is about 240,000 miles away. It takes light about 1.5 seconds to reach us from the moon. So when you look up at the moon in the night sky, you don't see it the way it looks right now. You see it the way it looked 1.5 seconds ago. Light from the sun takes about 8 minutes and 20 seconds to reach us. So if the sun were to explode right now, you'd have to wait 8 minutes and 20 seconds before you get to see the fireworks. So keep that in mind. When you're looking out in space, you are always looking backward in time. Okay, well, for our next object, we're going to go outside. We're going to look almost straight up again. Actually, we're going to look to the north, and we're going to look about 3/4 of the way up into the sky, and we'll see this view. Once again, we see the Big Dipper up near the top. The view is reversed this time because we've turned around. Before, we were standing outside facing south and looking straight up. Now we've turned around, we're facing north, and we're looking sort of 3/4 of the way straight up. So we see the Big Dipper up at the top. You see the Little Dipper down at the bottom. Big Dipper is part of the constellation Ursa Major. Ursa Major means the Great Bear or the Big Bear. It's named after another legend in Greek mythology. Some of you know that in Greek mythology, that the head guy in the Olympian gods was Zeus. And Zeus was a legendary god in Olympia, or Mount Olympus, I guess it was. And although he was a god, he liked the girls down on Earth. And he would quite often get girlfriends down on Earth, earthly human girls. Unfortunately, Zeus was married, and his wife, who was also an Olympian god, was Hera. And when he found out about Zeus paying too much attention to any of those earthly girls, she would get pretty upset. So there was a girl named Callisto that Zeus took an interest in, and Hera got upset. Callisto had a young son, and when Hera got angry, she changed Callisto and her young son into bears. And then she had them thrown up into the sky by their tails. So now Ursa Major, the big bear, is Callisto, and down below it is the Little Dipper, which is Ursa Minor, the little bear, and that's Callisto's son. And when you see them depicted in sky charts, you often see them as bears with very long tails. The reason they have long tails is because they were thrown by their tails up into the sky. Okay, so the object we want to look at right now in Ursa Major is the Whirlpool Galaxy called M51. It's located just off the end of the handle there. And this is what it looks like through Nellie. This is an image taken by Conrad Jung, our staff astronomer up here at Chabot. Conrad is a very excellent astrophotographer. Some of his work has been featured at the Smithsonian Institution. He's got the patience to do this. I do not, so you won't see me doing astrophotography like this. Astrophotography, good astrophotography takes a long time. It's a lot of work to do. But you see here a spiral galaxy. We're looking almost straight down on it. And you see another smaller galaxy nearby. And material is actually being passed from the smaller galaxy into the larger galaxy. And again, this is called M51, also known as the Whirlpool Galaxy. Now, this is a processed image. It was actually done by collecting a whole bunch of images over a long period of time, stacking them together, and then processing them very carefully to make all the fine details come out. But last weekend, actually, I guess it was 2 weekends ago,
yeah, I think it was
when we were testing out the cameras on Nellie to make sure everything was going to work for the virtual telescope observing that we aren't doing tonight, Richard Osier was up here with me, and Richard put a camera on Nellie, and he took a very quick image of this same galaxy. And we thought it'd be interesting for you to see how those initial images look before you do all the stacking and processing and everything. So here's an image. I'll let Richard explain to you a little bit about what's going on here.
Sure. Hi, everyone. So the camera I used for this is just a Canon EOS DSLR camera, just a standard, purchased at Costco some number of years ago. And they happen to be pretty decent for astrophotography. So this is a 20-second shot of the M51 Galaxy. And you'll see that it's got a lot of like staticky fuzziness to it. That's the kind of noise that we get whenever we're doing any type of astrophoto. And the whole game in astrophotography is to take enough images in order to beat down the noise. And as you take more and more images, and as you stack them, and as you correct for the noise on the sensor, you get more and more of that beautiful detail. But that takes a whole lot of time. So this is what you get for 20 seconds. And we also then stretch that image a little bit to kind of amplify it so it shows up nicely on the screen. And that's pretty much it. The software that you are looking at here is called Astrophotography Tool. It works really well with Nikon cameras, Canon cameras, and also CCD cameras. And is a great. Yeah, and it's a great way to integrate all the equipment that's used for astrophotography and you know, get some quick results if you want. I'll give it back to Gerald here.
All right. Okay, by the way, Richard used the term stretching. If you saw the original version of this picture, which you can kind of get a hint of over on the right there, the image has very little detail in it. You know, what detail is there is very, very faint. And when you do stretching, you basically find the brightest object in the image, which actually is not very bright. And then you stretch that object's brightness to the full range of the CCD. Typically, these things have 65,000 levels of brightness. And in a faint image, you may have only the brightest object in the image, maybe only at 20,000 brightness levels, what we call ADUs. So in stretching, you take that brightest pixel and you stretch it to where it's a full 65,000 ADUs, and everything else gets correspondingly stretched or brightened as well. And that's how you get all these details to come out here. It's a process that astronomers use quite a bit. Okay, let's go back to our PowerPoint.
Yep, I'll have to hit share again.
Okay.
Down at the bottom. Green.
There we go.
And double click on your PowerPoint. There you go.
All right, we're back to our PowerPoint. Okay, so we saw this object near the Big Dipper. We were looking to into the northern sky. We're going to go out again and turn around and look back south and look straight overhead again. And let's see, I'm going to get it to where it'll do it. There we go. So this is back to our straight overhead view. You're standing facing south, but you're looking almost straight up. Once again, Coma Berenices is there in the middle. To the left is the other constellation that I mentioned earlier, Boötes, right here. And if you have trouble pronouncing a word like that with the umlaut over the O, don't worry about it. You can always call it booties. And that's a constellation up here. Once again, it's got that bright star Arcturus in it. Boötes in legend is credited with inventing the plow. And Boötes is also responsible for herding the bears. So he's called the herdsman. And he is up there right next to Ursa Major and not too far from Ursa Minor, the big bear and the little bear. And in legend, his job was to herd the bears or guard the bears. So the object we're going to look at in Botes is called M3. So M3 is what we call a globular star cluster. It's like a ball of stars out in space. There are about 150 globular star clusters that orbit around our galaxy. They orbit in a region called the halo. So if you imagine being outside of our galaxy looking at it, it looks like a flat disk with spiral arms in it, something like what you saw with M51. Around that flat disk is a sort of a very fuzzy nebulous region called the halo. It completely surrounds the galaxy. And the globular star clusters orbit the galaxy in the halo. So they're not in the spiral arms, although they may pass through them as they orbit, but most of the time they are outside of the spiral arms. Globular star clusters are very old. The stars in the cluster are more than 10 billion years old. Because of that, most of these stars are relatively low mass stars. High mass stars, stars that are born with a lot of mass in them, don't last very long. They don't last 10 billion years. But low mass stars, stars like our sun or stars with even less mass than our sun, they can last 10 or 12 billion years. And so the stars we see in the globular star clusters are what we call old stars, and they're mostly low mass stars. Now, low mass stars should be mostly yellow or orange or even reddish in color. But if you look, you see a lot of blue stars in there. And for a long time, this confused astronomers. They did not understand how there could be blue stars in globular star clusters because the stars should all be old. If stars are blue in color, it means they're very hot. In order to be very hot blue stars, they have to be very massive. But as I said a few minutes ago, massive stars don't last very long. So how can there be all these blue stars in globular star clusters if all the massive stars have gone away? Well, you notice how all those stars are really close to each other towards the center? Turns out they bump into each other every once in a while. And when they bump into each other, they can strip away their outer layers, exposing the much hotter interior of the stars, or they can combine to form a new star more massive. And it turns out that's how you get blue stars, either stripping away the outer layers of the star to expose the hot interior, or by merging stars to produce a new, more massive stars. So these blue stars in globular star clusters, the term astronomers give to them is blue stragglers. Okay, let's see. We're going to go and look in a different direction now. We're going to look towards the eastern sky. And this is like, around 10 o'clock or so at night. And in the eastern sky, you'll see some bright stars just starting to rise. The one over on the left is Vega. Vega is the brightest star in the constellation Lyra. Right over on the right, just coming up, is the star Altair. Vega and Altair are two members of what we call asterism. It's a pattern of stars. This one is called the Summer Triangle. And later on in the summer, both Vega and Altair will be higher up in the sky, and they will be joined by a third star called Deneb. And those three stars make up the Summer Triangle. You see Arcturus and Boötes up near the top. In between Vega and Arcturus, we have another constellation called Hercules. And Hercules is another character in Greek mythology. He was the strong man and the hero. Now, this relates back again to our friends Zeus and Hera. Hercules is the half-brother of Zeus, and he was born much later than Zeus. And Zeus's wife, Hera, was not very happy about it. And she decided that the baby's Hercules should be killed. So she arranged to have some venomous snakes put in Hercules' crib when he was a baby. But even as a baby, Hercules was very strong and he killed the snakes. And so he grew up to be a very strong man, capable of many deeds. And he was given 12 labors to perform to prove his manhood. Things like killing a lion and defeating a dragon to save, I believe it was golden apples that he had to retrieve and so forth. So he proved his manhood by performing all these deeds. In Hercules, we have a very interesting, very popular object for amateur astronomers called M13. Now, actually, I'm going to back up here for a second. You see that region that I just pointed out, you see 4 stars there that form kind of almost rectangular or trapezoid shape. Those 4 stars we call the keystone because the shape that they form looks like a keystone, which is a special stone that you put in the top of a stone arch when you're building a stone archway over a door. So we call that the keystone, and on the western edge of the keystone is where we find this next object called M13. M13 is another globular star cluster. It's a big globular star cluster. We looked at M3 a little while ago. M3 is 33,000 light years away. M13 is much closer. It's between 23 and 25,000 light years away. And it has many more stars in it than M3 has. Once again, the stars are more concentrated at the center. And the reason for that is that the stars are actually orbiting around the center of the cluster in such a way that they form highly elliptical orbits. So they're like an oval, only it's a stretched out oval. And so the stars go in close to the center. That's when they're moving very fast in their orbit. As they pull away from the center and go out towards the periphery of the globular star cluster, they move very slowly. So there are a lot of stars moving very fast near the center, and as many stars out near the periphery, but they're moving very slowly. With these globular star clusters, not sure if all of them, but we think a lot of them have a black hole at the center called an intermediate mass black hole. So a black hole that has a mass of several hundred or a couple of thousand times the mass of our sun. And we think these objects are orbiting around that black hole. Okay, let's see. We got one more object to look at, and this time we're going to go back outside and look at our northern sky again. So we're looking up towards the Big Dipper. And you remember the Big Dipper was part of the constellation Ursa Major. In the Big Dipper, you see 2 stars we call the pointer stars. So here's Ursa Major, and I skipped over. I got ahead of myself. Okay, so we got Ursa Major, and in Ursa Major is another galaxy called M82. M82 is a galaxy that's a little bit, well, it's not real far away. It's 11.8 million light years away, but it's on edge from our point of view. So we don't see the spiral arm so well. And it's kind of a fuzzy object. We sometimes call it the cigar galaxy. And the reason I'm showing this to you is in 2014, there was a supernova explosion in M82. Now, supernovas generally there's 2 classes of supernovas. One class of supernovas happens when a massive star, say 8, 10 or more times the mass of our sun, when it dies, it explodes, and for a short period of time produces more light than the entire galaxy produces. And the other type is called a type 1A, which is a white dwarf that is in orbit around another star. The white dwarf is pulling material off of the other star, and eventually it reaches a point where it's got too much mass and it explodes. And so one or the other is the way we see supernova. So this supernova happened in 2014, and Conrad Jung was able to capture an image of the supernova. So you see that bright object there in the galaxy. Now, it's as bright as some of the other stars that you see away from the galaxy, but those stars are actually in our own galaxy. So they look bright because they're very close to us. But M82 is 11.8 million light years away. And yet this one star that exploded in M82 put out as much light as stars within our own galaxy did. So that was a pretty cool thing, and we just happened to catch it at the right time. It only lasted for a few days, and we were able to catch it. Okay, going back outside again and looking high up in the northern sky once more. This time, we're going to concentrate on the Big Dipper because there's two stars in the Big Dipper. These two right here are called the pointer stars. And the cool thing about the pointer stars is they help us find the North Star. So if we take the distance between the two pointer stars and we go 5 times that distance out of the bowl of the Big Dipper, it points us right at the North Star. And the North Star is not the brightest star in the night sky, contrary to popular belief. The thing that's unique about the North Star is that unlike all the other stars in the night sky, it stays right where it is all night long, all year long. And that's because if you take the axis of rotation of the Earth, our daily rotation around an axis, which goes from the South Pole of the Earth through the center of the Earth, up to the North Pole, if you extend that line out into space, it points almost exactly at the North Star. So as the Earth makes its daily rotation, all the other stars and the sun and the moon and so forth all seem to move across the sky. But the North Star stays right where it is all night long, all day long, all year long, and it'll be there 100 years from now. So it's a great way to navigate. Okay, so I think I've shown you enough images here. A couple other things I wanted to talk about. Some comets. Now, there's one comet that I was hoping I was going to be able to get some images of this week. It's Comet Pan-Starrs. Its official designation is C2017T2. And it's actually pretty high up in the sky right now. It's not bright enough to see with the naked eye, but it's bright enough to be easily seen with a telescope. And I was sure hoping that I'd be able to get some images of it. Unfortunately, Mother Nature's got other ideas. Recent observations of the comet. This is actually a picture of another comet, and you see the tail extending out. The recent observations of Pan-Starrs suggests that the axis of rotation of the nucleus in that fuzzy disk that you see at the center is the nucleus of the comet, which is actually a solid icy body. And recent observations suggest that the nucleus is rotating and its axis of rotation is actually pointed towards the Earth. So the reason you see all that gas around it is because it's gotten close to the sun and those ices are changing into a gas by a process we call sublimation. And that produces jets of gas that come off of the comet. Because the axis of rotation of the comet is pointed right at us, those jets of gas seem to form a kind of a concentric fan all around the nucleus. It's a very unusual effect that we're seeing. It's common for gases to be vented off of comets. That's what produces that long tail that you see. Those gases they come from the ices on the comet. They can be carbon monoxide gas, it can be carbon dioxide, they can be water vapor. One of the most common gases, though, to come off of comets is called cyanogen. And cyanogen has a very bright, distinct greenish color. And so quite often when we photograph comets, we see that they have a greenish color. Now there's another comet that you've been hearing a lot about, and that's Comet Swan, which is a C 2020 F8. It's actually has been bright enough to be seen with the naked eye. Unfortunately, to see it, you have to get up early in the morning, like 3:30 in the morning, and it's just above the horizon, about an hour or so before sunrise. So you have to catch it at just the right time because the sky is starting to brighten. And unfortunately, it's gotten so low that you really aren't going to be able to see it too well. Also, it's starting to fade as it moves away from us. So it's no longer really visible to the naked eye. You need a telescope to see it. Okay, well, that's about it. I'm going to open it up now for questions. You can ask either Richard or I. We'll be glad to answer any questions that you have.
I'm going to field the first one. Maria asked, hi everyone. Maria asked whether the SpaceX satellites that they're, what? Oh, I got to be in the top third. We were talking about composition of photographs before we started this presentation, and my head is supposed to be in the top third of the screen. The question was whether or not we're concerned about the Starlink satellites that SpaceX is sending up getting in the way of astrophotography and astronomical research. Certainly at first, it was a very, very big concern. And those of us in particular who are into amateur astrophotography were very concerned that we were going to get really washed out by those things because there were, tens of thousands of them planned. SpaceX has been doing a really good job addressing these concerns. And the most reflective part of the satellite is the antenna. And they realized that most of the problem can be solved by the orientation of the antenna and by putting a shield below the antenna to prevent any reflected light from hitting the Earth below. And they are right now anticipating that they will not be causing the type of problem that astronomers and astrophotographers were concerned about. This was only going to be a problem during astronomical twilight, maybe an hour after that, and then sunrise the following morning, maybe an hour before sunrise the following morning. So for astrophotographers, that's maybe, the worst case scenario was cutting a couple hours off of the night, which can kind of be a big deal if you're trying to get 6-7 hours of photos to have 2 hours cut off is kind of a big deal. But it sounds like SpaceX is doing the right thing and they're taking our concerns seriously. So kudos to them.
Good, good.
Let's see if there's any other questions here. Is the Mars 2020 rover a new project for your wife?
Okay, well, for those of you who don't know, my wife has built a 1/4 scale model of the Curiosity rover. She decided to make this a project when her employer purchased a high-end 3D printer. And so she figured out how to design a 1/4 scale model. She got some information from some other people on the internet, but she went whole hog, which is my wife's nature. She's one of those people who thinks if you're going to do anything, you might as well overdo it. So she made a highly detailed 1/4 scale working model of the Mars Curiosity rover. It actually drives, she can control it via Wi-Fi. It has the tool arm on it. It has a camera on it. It has a lot of the stuff that the actual rover has. And we've been taking it to, or we were taking it to various events at libraries and schools and so on. And the kids get a lot of fun out of it. We actually let them drive the rover and things. So I've actually been teasing my wife about whether or not she's going to make another one. She says she's not finished with all the things she wants to do with the one she has. So next question.
The next question was from a gentleman who mentioned that he had a telescope. It was a Celestron 60AZ, and he got it as a gift, and he's clueless as to how to make it work. And he's an engineer, but can't seem to figure the thing out. And this is not, don't feel bad. This is something that happens a lot. And my suggestion is always find an astronomy club, get hooked up with other people who are using telescopes, go to a star party, and the other attendees there will help you out. You'll figure it out, but you got to join an astronomy club to figure out how to use these things.
Yeah, unfortunately right now, because of the coronavirus situation, most astronomy clubs are not doing any formal in-person meetings. They're not doing outreach programs, star parties or anything like that. So you may have to wait a little while before you can do that. But once things get back to some version of normal, get hold of your local astronomy club. We have a club here at Chabot Space and Science Center called the East Bay Astronomical Society. If you're out in the Diablo Valley region, there's the Mount Diablo Astronomical Society. There's one down in San Jose. There's one in San Francisco. There's quite a few of them around the Bay Area. So get hold of your local astronomy club and they will help you out. Next question.
That was it.
Really?
Yeah, not many questions tonight.
Okay, well, if that's all, then I guess we will call it a night. We're going to do this again next weekend at 9:30 at night. We're doing it late at night because, the original idea here was that we would put cameras on the telescope and actually point the telescope at astronomical objects and show you views from the telescope. And unfortunately, because we're in daylight saving time and we're getting close to summer, it doesn't really get dark until after 9 o'clock. Astronomers usually wait for something we call astronomical twilight, which is when the sun is 18 degrees below the horizon. At that point, the upper part of the atmosphere is no longer lit by the sun. So that's when we see the most detail with our images, with our telescopes. That actually doesn't happen right now until around 10 o'clock, but 9:30 is when the sky is dark enough for us to start doing things with the telescope. So, if you folks have any influence with Mother Nature, please ask her to give us clear skies and low humidity next Saturday at 9:30, and we'll try to do this again and actually look through the telescope. So until then, have a good evening, stay safe, stay home, wash your hands, and don't forget to wear those masks. We'll see you later.